All right. Hello, everyone. We're going to be going over the exam one practice problems. So, exam one, it's going to be covering everything that you've done up to lists so far. It's not going to be too challenging, but the main thing that we want you to be able to do is look at some specifications for a question and see, well, how can I come up with a way to express this using Python? So the way that our questions will typically look is as the following. So here's an example that I've got on screen here. So this first one says, write a function that's called minimum terms or min terms that takes in an argument of n. This calculates the number of terms required for the sum of the following series to be strictly greater than n. So we've got a series right below, and we see that it's 1 squared, or 1 to the 1 over 2 plus 2 to the 2 over 4. So the main thing that we see is that there's a pattern. For our first element, we've got the first element, and then you raise it to the same power. So the thing on the top is going to be raised to this, same power as the base. And then you divide each term, it's going up by 2. So we really have to see, is there a way for us to generate this series using a loop? And we've got a few examples. So it says minimum terms of n equals 30 is equal to 4. So that means that only 4 terms would give us, if we calculated the sum of 4 terms here, it would be strictly greater than it. So same thing with 100, we would need 5 terms, and for 10,000, we need 7 terms. So how are we going to do this? First things first, we want to start out with all of our infrastructure. What do we need to do? We need to make sure that we've got the right name. So let's define our function. So in Python, we use the def keyword, so define, and then we need to look at, well, what is the name of our function? So we have min terms, and then our argument is going to be n, and n is just going to be some integer. Now, what do we need to do? Well, we need to initialize certain things that we're going to use for our checks. Let's start by just giving ourselves a variable that can hold the sum as we go through. We start adding. So we add our first two, and then we'll have to add it again because remember, when you add the third term, for example, you're adding it to the first 2 terms. So if we just say that the sum is going to hold our current sum up to this current point, then we can use that and just keep adding the next term to this sum variable, and it'll give us our next sum. Let's just start it out at 0. What else do we need? Well, we need to think, how are we going to generate this series? So again, if we look at the series here, and maybe I'll change the color here. Why don't we index it using something like the letter K? Let's use K as our variable to index this series. Well, let's say that this is the 0th term, and let me just write it below 0th term, or maybe why don't we just do 1 because I feel like that's more intuitive. Let's do the first term, and let's erase all of this. I'll get rid of all of this, make it a bit easier to see. That's our first term. That's our second term, third term, fourth term, etc. And now we need to see what is the pattern. How do we generate each individual term based on the value of K? Well, if there's something that we look at, we can see that, I don't know, for K equals 2, we can see that it would be K to the K over, right, because it's 2 to the 2, where K is equal to 2. And then it's just 4 on the bottom, which would just be 2 times K, right? So it'd be 2K. And again, this seems to work for all of them, right? Because if K is equal to 3, we have 3 to the 3, and then we have 2 times 3 is 6. And it seems to work for us. So let's use that. That's how we're going to generate our series. Now, let's start our index variable. So we're going to use it to loop over, however many however many terms we're going to need. So we're going to say k is equal to 1. And then we're going to make a loop. So let's make a loop. And the way that we're going to do this is using a while loop. And this while loop is essentially going to keep looping until some certain condition is true. And what do we want? It says that we want the sum to be strictly less than n. So what does that mean? It means that sum is going to be less than n. So when this condition is true, that's when we know when to stop. So let's do that. Right, our while loop. So while true, we have sum. And how we're going to, modify the sum every single time. Well, what's the first sum? Well, it's just going to be k to the k times 2k because, k is 1 currently, right? So it'll just give us this first term up here. So then we just need to write it in this form. So we'll say sum is plus equal because we've already initialized it as 0. And we're going to say plus equal k to the k. So the way that we'll do this in Python is do k and then use the power operator. Well, I think it's 2 asterisk actually. Okay, and then what? Divided by 2k. So divided by 2 times k. And then what? We need to check, is our sum now greater than n? So let's check. If sum strictly greater than n, then, well, we don't technically need to break. We could break, or I think an easier way to do this is just to return a value. So if we return now, the return, since we're in a function, what it will do is it'll end the function immediately and it'll just return that value. So let's just do that. Let's say return. And what do we need to return? It says we need to return this thing, right? The number of terms. So that would just be our k value, right? Because we started k as 1 and that corresponds. We've got 1 term, 2 terms, 3 terms, etc. So we'll just return k. And if this isn't true, then we'll just say k plus equal to 1. So we'll just increment k and keep going. And that should be it. So when you pass in 30 here, let's do 30, it'll check the first term and it'll check it, is 1 over 2 greater than 30? And of course it's not, so then we keep going. So we'll loop back. And then it's 1 over 2 plus 1 is greater than 30. Is this true? No, so let's keep going. So that'll just keep going on and on forever until it hits this condition, and then it'll stop. So that's that for that one. Okay, write a function for the next one. Write a function fizzbuzz, and then there's an argument max that will print the numbers from 1 to max. But if the number is divisible by 3, if the number is divisible by 3, then then fizz is printed. Okay, sorry about that. It seems a little bit weird worded, but that's okay. So basically, if the number is divisible by 3, we're going to print fizz. So we need that. Let's just highlight this. Let's highlight everything that we need. So, okay, that's going to be our function name. It'll print something. So print numbers from 1 to max. If it's divisible by 3, print out fizz. If the number is divisible by 5, print out buzz. And if the number is divisible by both, then we're going to print out fizzbuzz. So I guess just a combination of this. So fizzbuzz, as an example, you'll print out up to 3, so 1, 2, 3. But since 3 is divisible by 3, we'll write out fizz, and the same for 5. Well, 5 is divisible by 5, so it's going to be written as buzz, but 3 is still divisible by 3, so it'll be fizz, and that's why it looks like this. And here's a few more examples. Okay, why don't we start doing this? But what do we need to look at here? We've got a few different conditions. We know that we're going to have to do this. So if we've got a number like 15, as we can see right here, we're going to have to print out every number. 1, 2, 3, 4, 5, 6, 7, etc. Up to where? Let's see. I think up to 15, right? Yeah. So up to 15. And how are we going to do that? Well, if we just start our function now, let's look. So define buzz, buzz, and then let's do max as we specified. If we just want to print out everything, we would need to iterate. And the way that we can do that is by using a for loop, because as you know in Python, if we use the for some variable in the range, and then you specify, the starting value and the ending value, or of course the ending value plus one because it's not inclusive, we can iterate over everything. And the way we would do this is specify. Let's say for, I guess, num, and that just represents numbers. So for num in range, and since we want to start at 1 and go to 15 or max, we'll write it like this. So in range 1, because 1 is inclusive, and then we'll write max plus 1. And the reason why is because the second value is non-inclusive. So if we put 15 in there, it would print out up to 14. And of course, here you could put a print statement and it would just print all of them. But we need to do something to check. Like, is it divisible by both? Is it divisible by 3, 5, whatever? So the way we can do that is we can check. How do we check this? Let's look at 15, for example. As we're working with 15, what are the factors of it? We have 3 and 5. What about another number that's divisible by both? Let's see. We've got, I guess we could multiply it again by, by 2. And that would give us 30, right? So that would be 30. And if you notice what didn't change, it's this part, 3 times 5 in the prime factorization. And the reason why I do this is because I know you guys covered this in the previous lab, but we can see that since the factors 3 and 5 are going to be in any number divisible by 3 and 5, then we just have to check, is this factor, are these two factors, inside of this number? So how do we do that? Well, what's 3 times 5? It's just 15. So if we check, is our number divisible by 15? Or, if we check modulo 15, the remainder, if we divide by 15, if it's 0, then that means it's divisible by 3 and 5. And of course, for 15, that's pretty simple because it's just 3 times 5. And since 15 modulo 15 is equal to 0, it's also divisible by 3 and 5, evidently. That's how we're going to check first. So let's do that. Our first condition is just going to check, is it divisible by 15? So is num modulo 15 equal to 0? And if so, then we're going to print fizzbuzz. Put that like that. All right. And then we can check, is it divisible by just 3 and is it divisible by 5? And then we'll do the respective conditions. So elif num modulo 3 is equal to 0. And what do we need to print? I think we need to print fizz. So yeah, fizz here. So then print fizz. And then, all right, for divisible by 5 condition, print buzz. And then if none of this stuff is true, then we'll just print out the number. So print num. Great. So we're done with that one. And that should print out the correct things when that specific number is divisible by 15, 3 is 5. Again, 15 divisible by 3 and 5. All right, well, let's look at this one. This one's a bit more complex. It says write a function print square with a side length as an argument, which will print out a square with a given side length. If you put in 1 as a side length, there's just each side is just 1, and I guess this would represent square of 1, 1, 1, 1. This one, 2, 2, 2, 2, and I guess you represent that length of 2 by 2 asterisks. I guess same for this. How are we going to do this? It seems a bit more complex, but I think we can do this. Let's think about how we're going to, though, because this is a bit more confusing. So it's a square. You know, you have different conditions here. You've got like some that are at the top. You have just a bunch of asterisks in a horizontal line because it's the side here. So that'll be some different conditions to whatever's inside of this box, right? So we're gonna have to detect that. Now, how do we do that? Well, if we think about the last function that we just did, we had to iterate over every number from 1 to n. Now, if you notice here, since these have lengths of n, or whatever's being input in, I guess the side length, we can probably iterate that many times, and then we'll be able to do something with that amount because it's 7 by 7 in this case. So it's 7 by 7, so that means that we would have to iterate once to go vertically and once to go downwards. So let's try that. So if we have 2 for loops, maybe. I don't know how exactly we'll do that, but let's try it. So let's say that we've got for I in, and let me just make the function def, not def, def print square side length for I in range. So we're just going to do the same iteration for both because we want to iterate both up and down, or up and to the side, same amount. So 1 side length, I'll just put SL plus 1, and then I'll do another loop for J in range 1 SL plus 1. So we've got two variables I and J, and these variables store whichever one we're in right now. And if we think about this, let's say that we're in the first row. Let's say that I is equal to 1, because let's just, I is just the number of rows. Well, maybe I'll highlight that there. So if we're in the first row, we're going to have to iterate, again, 7 times. So J would be equal to, 0, or maybe let's just put 1, 2, 3, up to 7, right? And each one of these values here, since it's going to loop 7 times for every row. In the first row, when we're at index 1, or I is equal to 1, we'll have to print it 7 times. But notice that every time it's not 1, then we'll need to only print it at the very beginning and very end. So what I'm thinking is that we'll only print out 7 times if I is equal to 1, right? Because this is I equals 1. And then if I equals side length. So we can do that in our conditional. Same on the other side, I think, because that's just for I. Or I guess maybe we don't need to do that. For the way that we'll, avoid printing out all of these in the middle is we'll only print out if it's not these two conditions where we have to print out all the time, then we'll only print out when I is equal to 1, or I guess when J is equal to 1, sorry. I'm going to change color. So when J is equal to 1, and when J is equal to side length. Those are the only times we'll print otherwise. So let's do that. I think I'll just change color and make it nicer. So let's do that. So if I equals 1, or what is the other condition? If I equals side length. Then what do? We'll print out, I think, yeah, just print out all of them, right? Maybe we can include all the conditions here. So we could do, yeah, I'm thinking it only prints stars when j is equal to 1 as well, and when j is equal to side length. So we could actually just include all of this, right? Let's do that. So, or j equals 1, or j equals side length. And the reason why I'm doing this is because we're just going to figure out where the stars are printed. And we know that it's going to be printed when j is equal to 1, j is equal to SL side length, when I is equal to 1, and when I is equal to SL. So that's where these conditionals came from. So if this is true, just print out a star. So print, then let's just do star. And then let's just end it with no new line. But we don't want it to make a new line at the end. So we'll end it like that. Else, we'll just print nothing. So I guess just a white space. And then same thing. No new line after each print. And now once you finish, I think this is just one row, right? That's one row. Once you finish one row, you will print out a new line. So you could do print just like this. Print itself gives you a new line. Hopefully that makes sense. So the way that you can do this, if it was the way that you really think about it is just look, where do I need to print? Because this conditional that I made here just looks exactly where are the stars, and then prints it only when it's there. And it looks a little bit complicated at first, but in reality, you just need to know when the stars are printed and when they're not. Of course, when j is equal to 2, 3, 4, 5, 6, in this case, you wouldn't print. You'd only print when we're in the first column or the last column, and you'd only print in the first row and the last row, like everything. So that's how we're going to do that. This one looks pretty similar. The pyramid print. I think we've only got a couple more questions. So we're going pretty well. This one's very similar. Now, how are we going to do this? Let's do a similar approach to the last question. We see that, the way that we looked at the last question was we checked what are the different sides. Well, I just drew out a square to make it easier to visualize, right? Let's do that with this. So it says print out or write a function print pyramid, and it prints out an upside down pyramid of the given height. So I guess you could just think about printing out a pyramid that's just normal, not upside down, and flip the conditionals, or you can just flip the order that you do it. And that might be easier. And the way that you could do that is just do all the logic based on a normal pyramid, and then if you want to iterate like we did here, we iterated from I to the end of the side length. You can actually specify an extra argument in the range function to go backwards. You could start at the end, go to the beginning, and then put -1 as your how much you want to jump each time in the range function. So that might be a good way to do that. So let's look. Got a function print pyramid, we've got a height, and yeah. So let's see, how do we figure out what this variable says? Well, we see if height is equal to 1, let's say h is equal to 1, we just have a pyramid of length 1. Now, if it's 5, then we'll have a pyramid. Let's just look at it vertically, make it easier. We'll have pyramid height 5. And we can see that there's 5 rows. So there's 1, 2, 3, 4, 5. So that's how we're going to specify our height. 10, same thing, just bigger. Notice that in the first row, or I guess the base, so the base down here has height stars, right? Because it's h is equal to 5. And then as we go down, it becomes h minus 1, h minus 2, h minus 3, and then h minus 4. All right, and then we notice that since it's, can we specify that? Yeah, because we're just going down each time until we, subtract h minus 1. So the last one, of course, will just be h minus h minus 1. And of course, that just equals 1, right? So of course, the last one will have 1. That makes a lot of sense. So let's start trying to program this. Now, we know that it'll be a very similar approach to the last one. So let's just start it out the same way. Let's define our function. Find print pyramid 10. Well, sorry, not 10. What am I doing? We want our height, and I'll just use h. I feel like that makes it easier. Let's iterate. So since I want to do this vertically, instead of starting at, I guess technically this would be the first level. Maybe I think it would make more sense if this was height 1, this was height 2. Instead of starting all the way up at 5, which I know I wrote it here as h equals 5, technically I guess that would be h equals 1 because we're working vertically, the other way. Let's say for for num in range h 0, and the reason why is because we want to start at the value h, which is 5, and then go down to the base, and then we want to do minus 1, and the minus 1 just indicates going down. Okay, then we will, let's think, we need to print the amount of spaces, right? What do we need to do? Well, remember how we were starting from h equals 5 and counting down over here? We have to go down by 1 every single time and print out that many spaces, right? But how many would we be printing? Well, we would only be printing h minus the number, right? Because if we start at 0, and we start at 0, 1, 2, 3, 4, and we have h equals 5. So h equals 5, we print out 0 spaces. And then h equals 4, we print out 1 space on each side, right? That's how we're going to do this. We can do that by saying, let's start by printing out our first space, or our first spaces, right? Because we might have 1, 2, or 1, 2, 3. So for, let's say, that doesn't really matter. Let's just use x. We don't really need this. We just need to print some certain amount of time. So for x in range, let's say h minus whatever number this is, and that would just be num, right? That's how we defined it. We're going to print out a space, a white space, and okay. Then we're going to check, is it, or I guess we're going to have to print out our stars. What's next? Let's just check. Are we only printing a star after the first run? Think about that. So, and I guess since we've already printed out all of our spaces, we can now just see how many stars do we need to print for this specific row. So for the first row, we need to print, I mean, we print 0 spaces, right? So I think since num starts at h, if we, at our first row, it'll be h minus h. It will just print out no spaces. Now for the next one, we'll have to print out h spaces. So let's look specifically at what that means. So with our example 5, we're printing out h minus, it's 5 minus whatever this is. So if we start from 0 to n minus, let's say n minus 1, right? This is or h minus 1, sorry. So that's h minus 1. We make a new loop that goes up from 0 to h minus 1. We just have to print out h minus 1 stars. Or I guess if we loop through, let's do that. So let's say for star in range h minus 1. And again, this, when you don't put 2 arguments in the range function, it just starts at 0. That's what we did up there as well. Should just be able to print the print star because we've already printed out our spaces. End it with just a no space. And then once you get to the end, so that's just for one row, this whole thing, one row. Once you get to the end, you're going to need to print out a new line. So let's print out print. And then just print like that. And then we'll jump back to the next row. That should be it. Okay. Then we've got one more. So this is going to be on the last topic that's going to be inside of your lab. It's going to be about lists, or not in your lab, sorry, your exam. It's going to be about lists. This one appears to be a question that's very similar to one of the lab questions. I know that we did recursion in this lab about Fibonacci sequence because it's very intuitive if you're starting at 0, if you've got the series 0, 1, just to remind you of what the Fibonacci sequence is. You take the 2 numbers before it, add it, get the next number, take the next 2 numbers, add it, get the next number, 3, 5, etc. So it made sense because you're doing a calculation and you want to use that result for the next calculation. That's why we did recursion. However, here it appears we want to write a function that takes in the amount of numbers in the series and outputs all those Fibonacci numbers. So this is a bit easier because we don't need to calculate the sum, or I can't remember exactly what the lab did, but it seems like we're just going to put them all into a list, all of the Fibonacci sequence. So this is literally what we want to do. Just print all of them out up to a certain amount. And so if we input 0, it's going to be nothing. If we input 1, it's going to output just the first Fibonacci term. 10, first 10, I think. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Okay. How are we going to do that? Seems like we want to work with lists, so let's do that. We'll start by writing our function out. Define fib list. What do we want to put? We want to put count as our argument. And first thing that you need to know about creating series that are, recursive. I mean, because in essence, this is a recursive function, even though we're not going to solve this using recursion. It is a recursive function because you're generating the next value using previous values. So you always need to start. You always need to start with the first 2 because you're using 2 values to calculate the next one. So we'll do that. So what are the first 2 values? Well, we can just look at the example here and what I said earlier, 0 and 1. Those are the first 2 values. So let's start by saying that. So let's say init. Maybe we can just add stuff. Maybe it'll be easier if we just make a list that we can add to, because if we have the first 2, let's say sequence is equal to 0 and 1. So let's say as we generate the next few values, let's just add them onto this list. So now we've already got 2 values. We don't need to calculate them. We just need to start by calculating the third value, fourth value, etc. So if we've got count, which count, for example, in this case, 10, we've already eliminated 2, so we're going to count up to count minus 2. Let's iterate. So for I, iterator, in range, I guess index, I don't know what that means specifically, but I think that's what it is. Count minus 2, right? Because we're counting all the way up to 10 or whatever our count is, excluding the first 2 terms. We're going to add the next term. So we're going to use an append function. So let's do sequence dot append. And then what do we want to append? Sorry, I guess you don't use those square brackets. That's for accessing, but we want to use a function. So use parentheses. So we want to take the first value and the second value. And how do we do that? We've got, yeah, so we're going to add the previous value and then, the previous value. So if we're starting at an example 1 here, we're going to do just -1 and -2 in the list. So let's do that. So we'll do sequence -1 plus sequence -2. And remember, when you're using negative indexes, if you have this 0, 1, 1, 2, this will always give you the last 2. So it's not going to just be, 1 and 2. It's going to look for -1, which is here, and -2, which is here. It always starts at the end of the list and then goes back 1, goes back 2. And then that's it. So, it's just going to keep adding them until you're done. And once you're done with that, just return, what do we need to return? The list, right? So we need to return the sequence. I don't know if we need anything else specifically that we need to add to this, but I think maybe, let me see. I think we can just return the sequence and then, if we wanted to actually test this, we would just print. So we would just print fib list. Fib list and then some argument. So count. So that's it. So hopefully that helps. And, continue to go through these questions, make sure that you can conceptually think about how you'd solve them. And I'd always suggest look at the problem, try and think of the algorithm that you're going to use, solve it before you start programming. And I know that I kind of went quickly through this. However, it's best to really think what you're doing, because once you understand the problem, you won't have to spend so much time trying to figure it out as you code. And of course, the code doesn't need to be perfect. However, it will save you time. So anyways, good luck on the exam, and we will be meeting next time to work on the next lab. Anyway.